Pluto was once considered the ninth planet of our solar system, after its discovery by Clyde Tombaugh in 1930. For over 70 years, it held that status, despite its unusual characteristics. As astronomical techniques advanced, scientists began to observe that Pluto behaved differently from the other planets. It was significantly smaller, both in mass and diameter, than any of the 8 recognized planets. In fact, it is even smaller than some moons, including Earth's moon. Its orbit is also highly elliptical and tilted in comparison to the more circular and aligned orbits of the other planets. At times, Pluto's orbit brings it closer to the Sun than Neptune, further highlighting its anomalous nature. In the 1990s, astronomers made a groundbreaking discovery: the Kuiper Belt. This is a region beyond Neptune, filled with icy bodies and debris. Pluto was found to be one of the largest objects within this belt, but certainly not the only one. As more objects similar to Pluto were identified, including Eris, Makemake, and Haumea, it became clear that Pluto was not as unique as once believed. Eris, discovered in 2005, is nearly the same size as Pluto and orbits the Sun in a similar distant and tilted path. If Pluto were to retain its planetary status, logic suggested that these other similar bodies should also be classified as planets. The growing number of discovered celestial objects prompted the astronomical community to reevaluate what defines a planet. In 2006, the International Astronomical Union, or IAU, met in Prague to establish a formal definition. They concluded that, for an object to be considered a planet, it must meet 3 criteria. It must orbit the Sun, it must be massive enough for its gravity to force it into a nearly round shape, and it must have cleared the neighborhood around its orbit. Pluto satisfies the first 2 conditions, but fails the third. It shares its orbital zone with numerous other objects in the Kuiper Belt and does not dominate its region gravitationally. Because of this, Pluto was reclassified as a dwarf planet. This decision caused significant public reaction. Many people grew up learning about Pluto as the 9th planet, and its demotion felt like a loss. Even within the scientific community, the IAU's definition has been debated. Some planetary scientists argue that the requirement for a planet to clear its orbit is too restrictive and excludes interesting and complex objects like Pluto. Others maintain that a strict classification system is necessary to manage the growing number of discovered objects in the solar system and beyond. Despite its reclassification, Pluto remains an object of scientific fascination. In 2015, NASA's New Horizons spacecraft flew by Pluto, capturing detailed images and data. The mission revealed a world far more dynamic than expected. Pluto has mountain ranges made of ice, vast nitrogen plains, and evidence of possible cryovolcanism. Its atmosphere, though thin, contains layers of haze and undergoes seasonal changes. These findings challenged previous assumptions about what kinds of processes can occur on small, icy bodies in the outer solar system. In light of this, Pluto's demotion should not be seen as a downgrade, but rather as a redefinition that reflects our evolving understanding of the solar system. The reclassification allowed scientists to draw clearer lines between different types of celestial bodies, and has encouraged further exploration into dwarf planets and trans-Neptunian objects. Pluto now serves as the archetype of this new category, leading to a richer and more accurate picture of the cosmos. Ultimately, Pluto's story illustrates the dynamic nature of science. As new discoveries are made and new technologies allow us to observe more of the universe, our definitions and classifications must adapt. Pluto remains a key part of our solar system, not because of its title, but because of the insight it provides into planetary formation, evolution, and the diversity of objects that orbit our Sun. Its reclassification reflects the progress of planetary science and highlights the importance of continually questioning and refining our understanding of the universe.